Your room.
Yes.
Your me.
I know. Chalk, erasers. You never know. Okay, a couple. What now? So let's get started here. First of all, it's imperative that you know the difference between these two. Okay. Oops, that's the same. Okay. So here, write this down. It's not for my own enjoyment. I've already written this down once. Yeah, guys. So the base here equals -2, and the base here equals +2. So when you expand this one, I'll expand it to the left, it's going to be -2 times -2 times -2. But the second one has a -1 coefficient, 2 times 2 times 2. So it's important to really know that difference. We want to make sure that you can understand that, because it's an important one. It totally changes the meaning of the number. Okay, so brackets around your base implies that the negative sign is included. So let's start. In 6 exponent 7, 6 is called the base, 7 is called the exponent. And what's the whole thing called? Power. Okay. Then in 3x, 3 is called the coefficient. Now x is of course called the base again, but because it's a letter, we call it a variable base or variable. So the idea is that letters are called variables because their values vary. They can change. They're very elusive. So I got that down. Okay, next. So we're going to do right now some BEDMAS questions. Don't do the whole thing with your calculator. In fact, I'd never put a negative sign in for a base, because some calculators, if I enter that, it'll actually do this. So I never use negative signs in my calculator. Okay? I understand whether it's an odd exponent or an even exponent will change my negative sign. Odd exponents like this, cubed, means I'm going to get a negative answer. But if I have an even exponent like 4, then I'll get a positive answer. So what I'm saying is, be careful with your calculators, you calculator junkies. All right? You want to make sure you know how to use a calculator properly and watch your negative signs. Next, going on here, what's this one? Equal. Wrong. Expand it, please. -4 times 4. Ha! You fell for the fake brackets that mean nothing in this question. So you got to pay attention. Okay? The brackets aren't around the -4. A lot of you just thought you saw this. That's -4 times -4, +16. See how you got to be careful? Very, very careful. Do the next question. Evaluate this, then evaluate the second part. So don't do your subtraction until you get a value on the front and a value on the back. Using BEDMAS. Go. Following BEDMAS here, we have to evaluate this -4 squared as +16. And we have to do our brackets before we figure out what the exponent is. So -3 plus 2 is -1. -1 squared is +1. 2 times 16 is 32. Vanessa?
Would it be positive if you took away the brackets?
Why would I change the sign before I evaluate my exponents? BEDMAS. You're trying to do something down here, but you haven't found your exponent. As soon as you figure out your exponent, it's a positive one. So you changed your sign when you shouldn't have, because you got to figure out this value first. Okay, you haven't evaluated the exponent 2 yet. Okay, and that's a common thing to do. Yep.
Why don't you multiply it first and then do the exponent?
You're trying to solve like you would solve. Like if you had something like this, 2 bracket x plus 2. Because we have a variable, the only thing we can do is multiply in. And that's why we do that. Up here we know the values, so we have to figure out the answer in the brackets first. BEDMAS. Okay. Okay, next question. Again, here's a subtraction. It's the last thing you're going to do. Figure out your answers first. Go. Okay, so for this one here, we're going to get 9 plus 3 is 12 squared. We're going to get 36 plus, I use my exponent rule there. I don't really need to, but I'm going to go 3 minus 1 equals 3 squared, which is 9. So 36 plus 9. You don't have to do an exponent rule. You're welcome to go 27 divided by 3, which is 9. Okay. So then we get 144 minus 44. It's 45. And so our final answer is 99. Okay. All right. This next one is a little more complicated. You want to find these values first. Okay, find those values first. Go. You'll be using a calculator for that. Okay, so you get 702 over 117 plus 3 over 2. So that second fraction equals 6 plus the 6 from the 3 over 2. Total answer is 12. Okay, 6 plus 6, 12 is the final answer. Questions you guys have? Questions, Eliana? Okay. Okay, that's a pretty tough one because there's so much going on there. You got to do it in proper order following BEDMAS. Okay, don't just put it all into your calculator. You want to go piece by piece. So what we're going to do then real quick now is we're going to review the exponent rules. So you're supposed to do that one exponent worksheet, so you should be pretty good at these. We're multiplying the same base, whether it's letters or numbers, add them up. And so you get a exponent 7. When we're dividing, we subtract. So it's 18 minus 6. When we have a power to a power, we multiply. So that's a exponent 42. If you expand that out, there's 7 a6s. So it's a lot more than just 12 or 13. Okay, there's a whole bunch more. Now this second rule is the exact same rule, but a lot of you forget that we have hidden 1 exponents on the a and the b. So the 5 multiplies into the exponent on the a, and it multiplies into the exponent, which is a 1, on the b. So when we simplify, we get a5, b5. So it's not a new rule, it's just kind of expanding the idea up above. The next one is the new rule, it's just expanding again. What's the hidden exponent right here on the a?
1.
And what about the b?
1.
Now this 3 applies to both parts of the fraction, the top and the bottom. Here it's times 3, not 5. So it's a cubed over b cubed. Then we looked at exponent 0, that equals 1, but you got to be careful that, right, because 4 times a0 equals 4 times 1 equals 4. So be careful what the 0 is applied to. When we have negative exponents, this is the new thing that we introduced this year. Okay, 1 over a squared. It becomes positive. Now you have to be careful if we have something like negative 4 cubed to the negative 3, negative 4 to the exponent negative 3, that equals 1 over negative 4 to the positive 3. It doesn't change the negative sign of the base. It does not change the negative sign of the base. Okay? Common misconception. Now here, if we already have a fraction, then to make your exponent positive, it gets out of the fraction. Okay? I'm not timesing anything. It's just a squared. Times by the one that's there. Is that what you're asking?
Yeah.
Yeah. So that equals a squared because it's easier. Okay. All right. Here you go. 5 minutes. Go. Okay. So here we're multiplying. Get negative 6x 12. Add your exponents. Divide and get negative 4. Subtract your exponents. You get x3. Here, 1 times 3, x cubed, y 6. So it's going to be 2 cubed, x cubed, y 6, 8x cubed, y 6. Final answer. Okay. Next one is going to be 4 times 1 plus 1. So 4 plus 1 equals 5. Okay. So you have to really watch your base here. Here we're going to get 1 over 5 to the positive 2 equals 1 over 25. Here we get 6 to the positive 2 equals 36. Questions? Okay. Next one, correct your negative exponent. You get 3 over 2 to the positive exponent. So that equals 3 squared over 2 squared. Multiply it in. Okay, equals 9 over 4. Now, just want to let you know that's 3 exponent 1 times 2 over 2 exponent 1 times 2. It's not magically just sliding over. You're multiplying your exponents together, and you have hidden 1 exponents. Okay. Next one, only the base x has the negative 3. So nothing changes with the 6. Only the x and the 3 go to the bottom. Okay. Only if you have a negative exponent do you move. So for the next one, that'll be 36 over 8, and then we got to flip the other exponents. Okay. So what I did here is I flipped the 3 and the 5. And the only reason why I flipped both of them was because they both had negative exponents. And so now you get 36 times 3 all over 8 times 25. 8 and 36 can divide by 4. You get 2 and 9. And so you get 27 over 50. Final answer. Okay. Any questions? Yep.
What if there was only one negative exponent?
Then I'd only flip that one, and it'd be a multiplication of whatever there. So for example, if you had 5 squared times 3 negative 3 over 2 cubed times 4 squared, then I get 5 squared over 2 cubed times 4 squared times 3 cubed. Okay, so you flip and multiply what's there already. Yep.
Can't you multiply the bases first and you get 30 to the power negative 4?
No. Are the bases the same? So you can't do that. The rules don't apply. Okay. Only if the bases are the same can you apply the rules. Okay. Next, for your substitution, be careful. Use brackets. Okay, you want your exponents to look right and your bases to be correct, so use brackets when you substitute in. So this will become 2 times negative 5 in brackets squared. Okay, that'd be a lot different answer if I had no brackets. So 2 times 25 equals 50. Okay. All right, try the next two. Go. Okay, so here you have double negative signs because you have two negative signs. Don't think when you substitute in, there's one there already. Okay. So 4 times 2 minus negative 5 squared. Now I can correct my signs. So it's going to be 4 times 49. Well, 4 times 50 would be 200, and 4 less would be 196. So that's a great non-calculator question. Okay. So now we have some applications of exponents. So the volume of a cube is s cubed. Okay. Side times side times side. So there's 3 of them, and that's why we're allowed to write it as s cubed. Okay. So now we have 5 squared. Okay. We have 5 squared as the side length. So the final volume then will be 5 exponent what? No, 6. Okay, use your rules properly. Now go to your calculator. So I'm going to check that you'd use your exponent rules properly. Then I may even do another question where I check to see if you know how to use your calculator. So make sure everyone uses their calculator with the exponent button. That'll be centimeters cubed. Any questions? Area 1. So what we have to do is subtract our areas so that we have just the shaded area left over. So area equals, area the shaded equals area of the square, the whole big area, minus the area of the circle. So what we have is a square, s squared, minus the circle, pi r squared. So this would be 4 squared minus pi times, what is the radius? No, it's half of 4. 2. Okay. So this is 16 minus 4 pi. Now you can go to your calculator. Be careful how you do this. .43 meters squared. Okay. So then we go into bacteria questions. For the bacteria, we always had our starting population. Multiply it by an action, which is usually doubling or tripling, and then the exponent n will be the number of times. So our starting population is 1,000. It's doubling, so our action is 2, and it doubles every month, and we're wanting to know how much after 1 year. So how many times was it doubled? 12 months in a year. Okay, so now you can go to your calculator. 1,000 times 2 y to the x 12, 4,996,000. Back to insects. Okay. The next question is, how many 8 months ago? So we start with 1,000. We're still doubling, but how would we represent n since we're talking about 8 months in the past? -8. Okay. So some calculators can't handle that. So it's 1,000 times 1 over 2 to the +8. Which equals 1,000 divided by 2 to the +8. All calculators can do that. So you have to be able to multiply your fractions. .9. So what's the answer to the question? How many insects are there? Hands up if you think 4. Hands up if you think 3. Hands up if you don't think. Aha. So it's 3 insects. Okay, there's a few buns in the oven, but they're not insects yet, so we just leave it at 3. Do not round up for a question like this, because there's not another insect. Okay. Last example. Okay, Pythagoras question. So we want to know what x squared is first. X times x. So x squared equals the hypotenuse, 289, minus 225. So it's a Pythagoras question. So x squared equals, 64. So x equals square root 64, x equals 8. What I'm going to do is design questions so that you understand that square rooting is the opposite of squaring. Okay? That's really important to know. So technically this is happening. Okay, we're square rooting x squared to get to x. Any questions? Wait, turn to polynomials. We're just doing the front page. Okay, so the names. We have binomial, trinomial, monomial, and poly for the generic one. Okay. Here we have 2 terms. So what's it named? Binomial. 3 terms. 1, 2, 3. Okay. What separates the terms? Good, add or subtract signs. Okay. Now looking at degrees, we look at the terms. Okay, so here the x is degree 1, 8 is degree 0, so the highest number is 1, so it's a degree 1 term. Looking down below, we have x, which is degree 1. Here, what's x squared y? What's the degree of this one? 3. Okay, 2 plus 1, degree 0. So pick the highest number. What? Degree 3. Okay, after you find each term, you don't add again, you just pick the highest number. Coefficients. We have a -1 coefficient, that's it. For the next one, we have a +1 coefficient and a -4 coefficient. Okay. So coefficients are the numbers in front. Constant, +8, -12. Always include a value, plus or minus. Okay, makes it easier for you. All right, any questions? Okay, so next we did collecting like terms. So add up your x's, add up your constants. Right? Remember you have your little 1 tiles? How many little 1 tiles are there? We have -x squared minus 3x. Now you're welcome to write minus 3x minus x squared. This is in ascending order of terms, whereas typically we write it like this, descending order. Okay. Good. Next we did adding, subtracting polynomials. Nothing changes until we get to a subtraction. So when we subtract, we have to subtract both pieces. That's a little weird because it changes our signs. So we got our minus plus 5y, a minus -8x. Really our signs change to a minus 5y plus 8x. The beginning does not change. Only when we have a subtraction does it change. Okay. And so now we can collect like terms. Once we fix our signs, and remove our brackets. Okay, so go ahead, collect like terms there. So here we have a total of 3 plus 7 is 10, plus 8 is 18x. Negative 5 minus 3 is negative 8, minus 5 is negative 13. Why? Is that correct? Hands up, you got that? Okay, good. Okay, for the next one, be very careful. You have a sign here and here, which makes you correct everything. So remove brackets and correct your signs. Go. Remove brackets, correct your signs. Yeah, it changes to a minus 2x plus 5. But I do that when my brackets are gone. So you should have no more brackets then, Michaela. So 15 plus 2x squared, or you go 2x squared plus 15. Hands up if you got that. Okay, that's good. Watch your signs. You gotta fix them. X's cancel out because we have 2x plus 2x, negative plus. Okay. So if they cancel, don't write 0x. We don't need to even write them at all because anything times 0 is 0. Okay. That comes up in one of your homework questions, by the way. Okay, multiplication now. So this is just like what we did with the exponents. Multiply your numbers. So we had 15. And what do we do with our exponents? Add. Okay, do the next question. Go. Okay, now you don't need to show the middle step. You can go right to your answer. That's a pretty simplistic question. Okay. Dividing. So dividing, we subtract our exponents. Divide your coefficients, subtract your exponents. Do these next two questions. Go. Okay, so there's our answers for division. Make sure you subtract exponents when you divide. Now in your homework summer, it's like a negative 5 base times cube times negative 5 squared. Well, that equals negative 5. You don't need to use your calculator and get numbers just because you have numbers. Use your exponent rules. Okay. Next one. For multiplication, we have to multiply by both parts. You should be able to draw this. Okay? So when you're drawing this example, we have negative 2. We have 1, 2, 3 x's, and then minus 7. Shaded are negative. You'll be given that information on the test just to make sure that you're aware. And then for our answer key, you're going to redraw it, filling up the area, watching your lines. So here I get a negative, 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 and a whole bunch of positives. So negative 2 times 3 is negative 6x. You can see that in my diagram. And then plus 14. So you have to multiply with both parts. Be prepared to draw that and recognize it and divide it. Okay, so you have to know your algebra tiles. Man, Dave. I answered it? Yeah, you got to know your algebra tiles, okay? Okay, for the next one, this is a harder example which you can't use the algebra tiles for. So you got to follow your rules. So you're going to get a simpler one and then a harder one, okay? Go for it. Do this question. Okay. So there we have a harder question, harder answer. Okay. Watch your exponents. Make sure you're adding them when you're appropriate. Okay. Any questions? Okay. For the next one, you're going to have to multiply in. Don't forget to include the sign in front. I'm not multiplying in by a 4, but a negative 4. So you had 5 plus 3x minus 3 minus 4x minus 4 plus 3. Now I can collect like terms. Okay. 5 minus 3 is 2, minus 4 is negative 2. Oh, I screwed that up, didn't I? 5 minus 3 is 2. 2, negative 2 plus 3 is 1 minus x. Is it 1 minus x? No? What'd you get, Teason? Is it 1 minus x? Yep.
Is it the coefficient of constant? So wouldn't you add divided and together?
You have to multiply first, right there. It's multiplication. Okay. Okay, we're leaving it. Do the next one now. Multiply and then add. Be careful with that negative 2x squared. Go. You might not be able to add for this one. Double check that. Next one. Now we're into division. So when we divide, we can rewrite this as 18xy divided by 6y minus 12y divided by 6y. They both must get divided. Okay. So we're left with 3x minus 2. When letters divide, they divide to 1, which means there's got to be something left over. For the next one, you should have 1, 2, 3 terms. Go ahead and do the next division. Go.